This is the first of two videos to introduce you to the types of circuits you're going to learn about in this class. The first type of circuit that you're going to learn about is a series circuit, and the other one will be a parallel circuit. Right now I'm going to talk about series. So a series circuit is a circuit where there's one path for the electricity to take. So for example, if I were to line up 3 resistors like this, and connect them to a power supply or a battery, I would have a series circuit. And it's a series circuit because there's only one way for the electricity to go around this loop. Because there's only one way for the electricity to go around the loop, we could say that the current in this circuit is the same everywhere. Okay, so if this is my first resistor, the current through this resistor is the same as the current through my second resistor, as it is through the current through my third resistor. And so my current, I, is the same here, and even up here. Okay, so the current's the same everywhere. The other thing that's true about series circuits is that the potential difference, or the voltage, potential difference, or sometimes we could say voltage, it adds up to equal the total potential difference or voltage. Okay, so the potential difference voltage across each resistor is going to add to equal the total potential difference of the battery V. Okay, so if I were to write this out, I could say that total potential difference is equal to potential difference across my first resistor, so V1 across R1, plus V2 plus V3. So all the potential differences across each resistor add up to equal the total potential difference. If I were to apply Ohm's law to this, remember Ohm's law is equal to, it says V, my potential difference is equal to my current times my resistance. If I were to apply Ohm's law to this and do some substitution, I could say that my V total is the same thing as saying R total, so the total resistance times the current. I could say that V1 is equal to the current through that resistor times its resistance, R1. I could do the same thing for R2 or V2 and V3. And remember I said that the potential difference and the voltage, remember that I said that the current is the same everywhere, and so current is in all of these terms, so I can cancel that out because the current's the same everywhere, and I get R total is equal to R1 plus R2 plus R3. So for a series circuit, I know that if I add together all my resistors, I'll get the total resistance of the whole circuit. So for example, if this one is, say, 3 ohms, and let's say this one might be, let's say it's 6 ohms, let's say this one's 9 ohms. If I wanted to find the total resistance of this whole circuit, I could say that R total is equal to R1, which is 3 ohms, plus R2, which is 6 ohms, plus R3, which is 9 ohms. And I would find the total resistance of the whole circuit is 18 ohms. So the second thing I said about a series circuit is that the potential difference adds up to equal the total voltage. So each component, each resistor, has a potential difference across it that will add together to equal the total potential difference. And so for the sake of argument, I'm just going to add I'm going to say that the potential difference of this battery that we've hooked to this is 9 volts. So I've given it a value of 9 volts. And I want to take that information and I want to ask the question, I want to ask, what if I wanted to find the voltage across each resistor? Okay. Well, I could do that using Ohm's law, and Ohm's law tells me that V is equal to IR, and I know what R total is, and I know what V total is, because it's the voltage of the battery. So I could do some substitution and solve for my current first. So I'm going to divide by R total on both sides, divide by R total on both sides. R total will cancel out here, and I'm left with the equation V total over R total is equal to I. And remember, I is our current, and our current is the same everywhere. We said in the problem that this is a 9-volt battery, and so our potential difference for the whole circuit is 9 volts. And we said that our total resistance is 18 ohms. That's what we found earlier. And so I find that the current in this circuit is 5 amperes. Okay, so now how can I take that information and solve for the potential difference across each resistor? Well, I'm just going to use Ohm's law again. So let's solve for the first resistor. So I'm trying to find the potential difference across the first resistor. We're going to use Ohm's law, which tells us that V is equal to IR, and in this case we're trying to find the voltage across the first resistor, and so we're going to use the resistance of the first resistor. So I need to figure out what R1 is, I need to find I, and I need to find V. V1. Okay, so R1, if we look up at our diagram, we see that R1 was 3 ohms. So R1 is 3 ohms. Our current we found earlier is 0.5 amperes. And we're trying to find this potential difference. And so I'm going to use Ohm's law. So V1 is equal to I1R. And so we can just do some substitution now. My current is 0.5 amperes. My resistance is 3 ohms. 1/2 times 3, I get 1.5 volts. Okay, so the potential across the first resistor is 1.5 volts. Let's go ahead and do them all. So let's find the potential difference across the second resistor. R2. Okay, so R2, I, and V2 is what we're going to need to do this. If I look up here, I see that R2 for this one is 6 ohms. 6 ohms is my resistance. It's an ohm. My current, because it's a series circuit, is the same everywhere, 0.5 ohms. And my potential difference is what we're trying to find. So I'll write out my Ohm's law. V2 equals I times R2. V2 is equal to 0.5 amperes times 6 ohms. I find that V2 is equal to 3 volts. Okay. And for the last one, let's do the potential difference across R3. So we need R3, we need I, and we need V3. So R3, we look up here, we see it's our last resistor, it's 9 ohms. R3 is 9 ohms. The current's the same everywhere, 0.5 amperes, and we're trying to find the third voltage. So V3 is equal to I times R3. So V3 is going to be equal to 0.5 amperes times 9 ohms, and V3 I get 4.5 volts. Alright, so remember at the beginning of the video I said that the potential difference across all of these resistors is going to add to the total potential difference. So let's check that. So all of my resistors potential difference should add to 9. So let's see if I get that. So V total should equal V1 plus V2 plus V3. And so V total is equal to 1.5 plus 3 plus 9, or not 9, 4.5. 4.5. I add these all together, and I see that V total across all the resistors adds to 9 volts. This was volts. And so that checks out because that is the potential across the entire circuit. Alright, that's it.